Okay, in this lesson we're going to write a third-degree polynomial function with the given zeros 1 and 3i. The imaginary root theorem states that if you know one of the imaginary roots and its conjugate is also a root, so I'm going to add negative 3i to the list. And now I'm going to write this in standard form. And I'm going to start by writing my zeros as factors. So to do that, you just simply take them and put them back into factored form. If 1 is a 0, then x minus 1 was the factor. And same is true with x minus 3i and x minus negative 3i, which makes that an x plus 3i. Next, we're going to multiply 2 at a time. Now I'm going to choose to multiply these two instead of these two because I know that when I multiply conjugates that the template I'm going to use is a squared minus b squared. This is a plus b, a minus b format, so I know that the answer to that is going to be a squared minus b squared. I'm going to write this x minus 1 out in the front, and when I multiply these two together I'm going to get x squared minus 9i squared. And I know that when I see an i squared I'm going to trade that out for a negative 1. When I trade that out for negative 1, I get x minus 1 times x squared. It's going to change this to a plus 9. That negative 1 and that negative make that a plus. Now I'm ready to multiply these binomials together. I'm going to start with x, and I'm going to multiply it by x squared. That gives me x cubed. And then x times 9 is plus 9x. Now I'm going to move to the negative 1 and distribute it as well. Negative 1 times x squared is minus x squared. And then negative 1 times 9 is minus 9. And finally what I want to do is get this in standard form. I need to rearrange the terms so that I have descending powers. So I'm going to trade these two out and this will be my final answer. So that is the answer to question number 19. Next I'm going to do number 20, and again I'm given a negative 5 and an imaginary root of 1 minus I, so its conjugate is going to be 1 plus I. And that's a complex conjugate. Written in factored form, this is going to be x plus 5 because that minus negative 5 changes that to a plus. And then this could be tricky, but it's going to be x minus 1 minus I and x minus 1 plus I. And again, that's just simply how you do it. You put it back into that template, x minus inside the parentheses. I'm going to clean up these last two sets of binomials. I'm going to distribute that negative to the inside. I'm going to get minus 1 plus I. And the same is I'm going to do the same thing here. That's going to be minus 1. And then that minus times that negative gives me minus I. It'd be safe just to multiply these first and then add that to it just like when we did the last problem. To do so, you're going to start with the x and you're going to distribute it down the line. Then you're going to move to the negative 1, do the same thing, then the I, and do the same thing. So let's start with the x times x. That gives me x squared. And x times negative 1 is minus 1x. X times negative I is negative xi, and the order there doesn't matter. Now I'm going to distribute the negative 1. Negative 1 times x is again negative 1x. I'm going to line it up with this one above it. And negative 1 times negative 1 is a plus 1. Since there's no constants, I'm going to add its first column to that. And negative 1 times a negative I is a positive I. So I'm going to add that positive I on the end here. And finally, I'm going to distribute the I. I times x is a positive xi. I times negative 1 is a minus I. You can kind of see what's going to happen here. And then I times negative I is negative I squared. Now, if I add these three lines together, I'm going to get x squared minus 2x And you'll see that these two canceled out and the i's canceled out. And I'm going to trade my I squared for -1, so that's going to be a minus -1, which makes that a +1. And I'll add that to this +1 right here, so that's actually going to be a +2. We're not done because we have to bring down this x plus 5 and now repeat that whole process. It won't be so difficult now because we don't have all the i's in the way. X times x squared is x cubed. X times -2x is minus 2x squared. And x times 2 is plus 2x. And now let's distribute the 5 down the line. 5 times x squared is positive 5x squared. 5 times -2x is minus 10x. And 5 times 2 is 10. And now if we add these two lines together, we'll have our final answer. And that'll be x cubed plus 3x squared minus 8x plus 10. And that should be the answer to question number 20. Let's see if we have time for one more. Number 21, a little bit easier than number 20 actually. Again, we have a imaginary root, so we know that its conjugate is also a root. So putting that back in factored form, I'm going to have x minus 2, x minus 4i, and x plus 4i as a result of that minus negative. That makes that a plus 4i. And again, I'm going to start with these latter two because they're conjugates of each other. And we know that the pattern a minus b times a plus b is a squared minus b squared. So I'm just going to put that x minus 2 out there in the front. And when I use the a squared minus b squared pattern, I'm going to wind up with x squared minus 16i squared. And we're going to trade that I squared out for a -1, which makes that a plus 16. So I'll have x minus 2 times x squared plus 16. And now let's multiply x minus 2 times x squared plus 16, and we'll be done. X times x squared is x cubed. X times 16 is plus 16x. Distribute the -2. -2 times x squared is minus 2x squared. And -2 times 16 is minus 32. And as you can see, this isn't in descending order yet, so let's just go ahead and rearrange some of these terms. I'm going to make sure that my powers are counting down. And this is your answer to question number 21, and that concludes this lesson.